In this video, we are going to find all positive integers a, b, and c, such that 1 plus 2 to the power a plus 3 to the power b equals 6 to the power c. Before we move on, don't forget to give a like, subscribe to our channel, and turn on post notifications. This equation can be solved with one simple trick. We can consider the remainder of both sides when divided by 8. So for the first term on the left, it's always 1. For the second term, 2 to the power a, the remainders can be 2, 4, and starting from the third power is 0. The remainder is 0 all the way down. It's always 0 forever. And for 3 to the power b, the first one will be 3, and then 3 squared is 9, which is congruent to 1 mod 8, so the remainder is 1, and then it goes back to 3 again. So it's somewhat a periodic sequence with 3, 1, 3, 1 all the way down to infinity. Now for the right, for powers of 6, the first one has remainder 6, and then the second power 36, remainder is 4, and starting from the third power is 216, and in fact it's a multiple of 6 cubed, and which contains 2 cubed in the prime factorization. So that means starting from the third power, same as powers of 2, the remainder will always be 0 forever. So let's see what happens if the remainder at the right is 0. Then looking at the combinations at the left, the only possibility for that to happen would be taking 1, and then for powers of 2, it has to be 4, no other choice, and for powers of 3, it can only be 3, no other choice. So if c is at least 3, then that means we must have a equals 2, and so that means we have 5 plus 3 to the power b equals 6 to the power c. But this equation is absurd because the terms 3 to the power b and 6 to the power c are multiples of 3, and there's a 5 here, which is not multiple of 3, so clearly no solution. Now the only possibility that remains will be c equals 2 and c equals 1. Then 1 plus 2 to the power a plus 3 to the power b equals 35. And since a and b have to be positive, then that means there are only very few possibilities to consider. Indeed, b is at most 3, so either 1, 2, or 3. Then so this should be 36. I'll move the 1 to the other side so that the sum of the two powers is equal to 35. Now if b equals 1, then 2 to the power a will be 32 or 23 or 8. So that means a equals 5 or 3. From this we know we have two sets of solutions, 5, 1, 2, and also 3, 3, and 2. So that's what happens when c equals 2. And finally, when c equals 1, then 1 plus 2 to the power a plus 3 to the power b equals 6. So clearly the only solution is a and b are both equal to 1. So therefore we have 3 sets of solutions, 5, 1, 2, 3, 3, 2, and 1, 1. So this is the final answer. Please feel free to share ideas in the comments. Thank you for watching. See you next time.